Hello, everybody. My name is Lakshmi Harinath. Thank you for joining us today. I was told that I have to give a brief introduction about myself and then talk about the project. So, I did my first professional degree in medicine from Mumbai, India, after which I went into research in medical informatics at the Oregon Health and Science University. I then came back into pathology and did my residency from Allegheny General Hospital in Pittsburgh, followed by a cytopathology fellowship at the same place. After which I joined as a clinical instructor and come fellowship at UPMC and did my breast and GYN clinical instructorship here. I really liked the place and the people so much that I continued on as faculty here. So currently I'm signing out breast GYN pathology and also cytopathology. So I'm going to start talking about my project with a little bit of background. Everyone knows that the state of art artificial intelligence is currently of considerable interest in the health industry, basically because it is really quick, efficient, and provides automated, accurate pathologic screening and diagnostic assistance. There has been tremendous progress in interpreting complex anatomic images because of the developments in the fields of deep learning and increasing computational power that is being seen nowadays. So, this kind of progress has actually the potential to help tackle barriers such as delayed reporting and staffing shortages faced by labs all over the nation. The accuracy of such, AI-aided diagnosis is similar or higher than that of an expert pathologist in tumor detection and classification, as reported by some studies. However, there are no quality control systems in effect in the current time. So the title of our project is the determination of an optimal quality control method for Pap test analysis using digital cytology and artificial intelligence. So how we are planning to do that is we will be looking at a total of 500 archival Pap test cases that have been previously signed out, and these will be identified from our lab information system. We use the COPATH currently, and we may be shifting to Beaker in the near future. The slides will be retrieved from our archives, they will be de-identified, and all of these slides will then be digitally scanned with the Hologic Genius digital cytology system. After that, a cytotechnologist and a cytopathologist will then perform the initial interpretation of the AI-generated results, and this interpretation will then be compared with the previous manual interpretation. Once that is done, all the cases will then be subjected to 3 different methods of quality control. In order to undertake this, the cases will then be randomly divided into the following 3 groups. Group A will have cases that will be interpreted by a different person, pathologist or cytotechnologist, who will look at the AI-generated output. Group B will have cases that will be rescanned and the generated images will be diagnosed by the same person who performed the initial interpretation with the AI system. And Group C will have cases that will be rescanned with repeat AI-generated images that will be interpreted by a completely new, different person. The results will then be analyzed for concordance and discrepancies in the interpretation, and the discordant findings will then be resolved by consensus, where different expert pathologists who routinely sign out cytopathology cases here at McGee will arrive at an agreed upon diagnosis for each case. The findings will then be presented at the national meeting of the American Society of Cytopathology, and the results will be disseminated in the form of a journal article in the JASE. So basically, access to digital slides and the AI algorithm-generated image galleries provide increasing opportunities for augmented screening, for remote primary diagnostic work, for teleconsultations, training, collaborations, and other innovative research. And additionally, such changes have the potential to impact workload, and they also introduce efficiency to each lab that are planning to adopt them into their regular daily sign up. As we transition to a digital workflow coupled with AI, we do need to rethink about how we perform QC practices because we need to maintain standards, and we also subsequently need to develop best practice guidelines for the cytology community. So we hope that our study will advance this goal by contributing evidence-based data to help determine an optimal way to perform quality control in digitalized gynecologic cytology specimen. Thank you so much to the American Society of Cytopathology for the grant and for providing such a platform to disseminate the research results. Dr. Liron Pantanowicz and Dr. Momin Siddiqui, Dr. Robert Gulat and Barbara McGahey-Frayne, who are the co-chairs of the ASC Foundation Board, Dr. Bhargav and Dr. Zhao, who are the Chief of Pathology and Director of Cytopathology here at UPMC McGee Women's Hospital, Dr. Sarah Harrington from Hologic, Beth Jenkins and Jamie Rice for all the logistic support and for helping me put this together. Thank you so much and hope to see you all at the meeting when we talk about our results of this project. Thank you and have a great day.